Okay, so today we are going to learn about angles in the standard position. So angles are in the standard position when the vertex is on the origin and initial arm lies on the positive x-axis. Let's say this is an angle, so the vertex lies on the origin and the initial arm on the standard pos- positive x-axis. So if we do it like this, the angle is called positive angle. So the terminal arm can lay in any quadrant. The angle is measured by the amount of rotation from the initial arm to the this is the terminal arm, this is the initial arm. The angle from this to this is called the angle. If the rotation is counterclockwise, then the angle is positive. Now what is the clock? This is the clock 12, 1, 2, 3. So if the rotation is like this, it's clockwise. If the rotation is in the opposite way like this, it means like this, it means it's counterclockwise. Okay, so if the rotation is like this, it's going counterclockwise. Counterclockwise represents positive angle and clockwise represents, this is going clockwise. Clockwise represents negative angle. So if it is counterclockwise going like this, it means it's positive angle. If it's clockwise like this, it means it's negative angle. Okay, so draw the following angles in the standard position. Number A is 100 degrees. So 100 degrees is a positive angle. So we will go counterclockwise from 0 to, this is 90, this is 100. So this is 100 degree. Okay. Next is minus 60. So negative angle will go counterclockwise. This is 90. This is 90. Okay. So we're going to go 60. It would be less than 90. Minus 60 degree. 250 degrees means this is 180 and this is between 180 and like this. It would be 250 degrees. Minus 130 means going counterclockwise, so it's 90, more than 90. So it's going to be minus 130 degrees. Okay. Consider the angle theta is equal to 25 degrees. Draw 25 degree in that standard position. So how to draw 25 degree in the standard position? Okay. Draw a negative angle with the same initial and terminal arm as 25 degree. Now we are going to draw a negative angle with the same initial arm as this. This is the initial arm for the 25 degree. So this will be the initial arm for the negative angle and the terminal arm will be for the 25 is this, so same terminal arm. Same initial, same terminal arm. So the angle would be minus 335 degree. How did we know? Because total angle is 360 minus 25. So it will give us 335 degrees. So it would be minus 335 degrees. Can you find a positive coterminal angle of 25 degree? So how to find a positive coterminal and negative coterminal? Positive coterminal is equal to 25 degree plus 360 degree, which is equal to 385 degrees. Negative coterminal is equal to 25 degrees minus 360 degrees, which is equal to minus 335 degrees. Okay. One full rotation of a circle represents a 360-degree turn. We know there are 360-degree turns in one full rotation of a circle. Complete that circle on the right, showing where the angle multipliers of 30 degree and angle multiples of 45 degree would intersect at the circle. So if this is a circle, it has 0, 90, 180, 270, and between 0 and 90 there are these numbers. So it is total of 360 degrees on a circle. Okay. It is 0 degrees or 360 degrees. 30. After 30 it's 45, then 60, then 90, 120, 135, 150, 210, 240, 270, 315 and 330. Measuring angles. whose idea was it to measure the angles in degrees, and why are they 360 degrees in full turn? This decision actually dates back to almost 4,000 years. Degrees were created by the Babylonians, ancient people who lived in the region that is now Iraq. The Babylonians are also based the number system called sexagesimal system or 60 instead of base 10. What is radian? Okay, so here we're going to learn another unit that is used for measure the angle, that is called radian. So what is radian? And the angle made when we take the length of one radius from here, one radius from here, and one radius from here. Take the length of one radius and wrap it around the surface, that is called one radian. So what is one radian? It is the same length taken from, so one radian in angles is equal to, it is one radius r, then we will take the same distance from here, radius r, and same distance from here, radius r, so it will result in 1 radian, and 1 radian in the degrees is equal to 57.3 degrees. Working in radians, what if we cut pi radians into quarters? Pi radians into quarters means we will get pi by 4, 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4. Can we also say pi by 4, pi by 2, 3 pi by 4, and here we can say it pi. Okay. We can also write it in the form of the degrees. 45 degrees, 90 degrees, 135 degrees, 180 degrees. What if we cut pi radians into thirds? Now we're going to cut in thirds. Pi by 3, 2 pi by 3, 3 pi by 3. We can also write it 60 degrees, 120 degrees, 180 degrees. What if we divide pi into 6 equal bits? So dividing into 6 equal bits is pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, 6 pi by 6. We can also write pi by 6 as pi by 3, which is equal to 60 degrees, 30 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees. Okay, now let's put it all together thinking in radians. Quadrilateral angles, pi by 2, pi, 3 pi by 2, 2 pi. So all of these angles are called quadrantal angles. So multiples of pi by 4 or 45 degrees, all the multiples of pi by 4 will give us 45 degrees. All the multiples of pi by 3 will give us 60 degrees. All the multiples of pi by 6 will give us 30 degrees. So what is happening over here? We can write it 0 or 2 pi, pi by 6, pi by 4, pi by 3, pi by 2. Second, was the first quadrant. Now it's second quadrant, so it would be 2 pi by 3, 3 pi by 4, and 5 by 6 pi, 7 by 6 pi, 5 by 4 pi, 4 by 3 pi, 3 by 2 pi. The measurements below describe angles, indicate where the terminal arm of each of the angle would intersect the circle. The first one has been done for you. So 95 degree the terminal arm will come over here. Okay. So for 1 degrees, it's going to come like this. 1 degrees. Okay. 1. Pi. Pi will come over here. Pi. Pi by 2. Or in 3 pi by 2. 3 pi by 4, sorry. 5 pi by 3. 11 pi by 6. 4. Okay. Coterminal angles. Coterminal angles are the angles who share the same initial side and the terminal sides. Finding a coterminal angle is as simple as adding or subtracting 360 degrees or 2 pi from the angle you started with. Every angle has an infinite number of coterminal angles. Draw the following angles in the standard position and then one positive and negative coterminal angle. Okay. So 5 pi 6. How to draw it in the, this is in the standard position. Positive coterminal angle is 5 pi by 6 plus 2 pi, and negative is 5 pi by 6 minus 2 pi, minus 7 pi by 6, 17 pi by 6. Okay, this is minus pi by 4. Positive is going to be minus pi by 4 plus 2 pi, 7 pi by 4, minus pi by 4 minus 2 pi, minus 9 pi by 4, 2 pi by 3. Okay, 2 pi by 3 plus 2 pi, 8 pi by 3, 2 pi by 3 minus 2 pi. Okay. Also, we need to draw the coterminal angles. Seventeen pi by 6 starting from the terminal line. This is the positive coterminal angle that I am drawing. The red one is the positive coterminal angle, and I will use purple for the negative coterminal angle. Okay, cooler here. Identify the quadrant where the terminal arm of each of the angle is located. So 5 pi by 3 would be in which 5 pi by 3 would be in fourth quadrant, negative third quadrant. Problem set 6.1. Circle the answer that is closest to the measure of the angle in standard position. Some answers are in degrees and some are in radians. If an angle measure does not have a degree, it is assumed to be in radians. So if it has degree, it means it is in degrees, otherwise it is in radians. So this is less than 90, so it must be 85 degrees. Now this angle is greater than 180, less than 270, it must be 255 degrees. This is complete pi. This is less than pi, not 4, it must be 3. It is 0. More than 90, so it should be 100. More than 180, so it should be 200. This is complete 360 degrees, 2 pi. Less than 360, 315. 30 degrees. Near to 360, 340. Very easy, 3 pi by 2. Okay. So identify the quadrant where the terminal arm of each of the angle is located. 1, 4, 2, 3, 3. You can also, as it is, they are given in radians, not degrees, so you can also convert them in degrees and then check them out. For example, it is 5, so we need to multiply it with 57.3 and we will get 286 degrees, which is in quadrant 4, so it is 4. So you can convert them in degrees and then you will easily identify it in which quadrant does it lies. Write the equivalent angle measure in radians. 30 degree can be written as, okay, to convert from degrees to radians, multiply by pi by 180. Okay, so write the equivalent angle measure in degrees. Now we are going to convert in degrees, and to convert in degrees, you need to do the opposite, that is multiply by 180 by pi. Okay. Sketch each angle in standard position and give one positive and one negative coterminal angles. Okay. So we are going to sketch 150 degrees. Positive will be we will add, and in negative we are going to subtract by 360. 225. Minus 90 degrees. 5 pi by 4. Going to be 225. Multiply by, oh sorry, plus 2 pi and minus 2 pi. Okay. Okay. Complete the circles in degrees showing where angles with multiples of 30 degrees and 45 degrees. Simply writing the degrees over here. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 225 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees. Okay. Complete the circle in radians showing all of the angles with multiple of pi by 6 and pi by 4 intersect the circle. 0, 2 pi, pi by 6, pi by 4, pi by 3, pi by 2, 3 pi by 4, 5 pi by 6 and pi. 7 pi by 6, 5 pi by 4, 4 pi by 3, 3 pi by 2, 5 pi by 3, 7 pi by 4. Okay. Okay. So we are done with the first exercise. Thank you so much for watching this. I hope you have enjoyed this. Must subscribe the channel and must comment if you like the video. Thank you so much. Allah Hafiz.